Hi, everyone. Welcome to section 2.1, quadratic functions and applications. So what we're going to be doing today is that we are going to go over the graphs of quadratic functions. This is called the general form of a quadratic function, and we are going to rewrite it as a vertex form. What do we know about a quadratic function? So a quadratic function is a function that contains a second degree polynomial. So y equal x squared is our basic parabola that opens up, that has a parabolic shape. The parabola opens up if the leading coefficient a is greater than 0. Now, if it's negative, it will open down for a being less than 0. So y equal x squared, a in that case is 1. So 1 is greater than 0, so it will open up. Now, if I have y equal negative x squared, a is equal to negative 1, which is the leading coefficient of x. Negative 1 is less than 0, so it will open down like so. Now, our goal is to reorder that into a vertex form where I'm able to identify what is h, what is a, what is h, and what is k, because there's something special about a parabola and that it's its vertex. What does a vertex do? The vertex is actually our highest or lowest point where we can identify the axis of symmetry, x equal h. So in this case, our peak, this point is h comma k, and this axis of symmetry is x equal h. Where we cut our parabola in half, that is our axis of symmetry, x equal h. Here, a is less than 0. It's a negative opening downward, and then we have a parabola here. This is our vertex, h comma k. Now it opens up, so here, a, the leading coefficient, is greater than 0. So we want to identify what is a, what is h, and what is k. Well, for the first question, we have f of x is equal to a, parentheses, x minus 3 squared. If we rewrite it in order, minus h plus k, we can identify that negative h is equal to negative 3. That means that h is 3. It's actually a positive 3. A, the leading coefficient, is 1. We don't see 1. So if you don't see it right in front of it, that means that a is 1. That means that a is greater than 0, therefore it will open up. H is positive 3, and k, well, k is equal to negative 9. K is equal to negative 9. So my vertex is h comma k, which is 3 comma negative 9. My axis of symmetry is x equal k, but we know, sorry, x equal h, but in this case, x is equal to 3 because h is 3. So let's go ahead and graph it. What do we know? We know that our parabola will open up and we have a vertex of h and k. What else are we missing? We're missing the x and y intercepts because we're interested in graphing. How do we find the x-intercept? We let y equal 0. Let's go ahead and do that. So we have 0 is equal to x minus 3 squared minus 9. Let's bring the 9 over by adding x minus 3 squared. How do we undo a square? We take the square root of both sides, but therefore we get a plus or minus on the other side. We get 3 is equal to x minus 3, and negative 3 is equal to x minus 3. So we have two x-intercepts. We have x, if we add both sides by 3, I get x equals 6. If I add 3 on both sides, I get x equals 0. My x-intercepts are the points 6, 0, 0, 0. Now my y-intercept, to find the y-intercept, you let x equal 0 for my original equation. So f of 0 is going to be equal to 0 minus 3 squared minus 9. We're substituting that into the equation. We get negative 3 squared minus 9. That's going to give us 0. here, negative 3 squared is 9 minus 9, that's 0. So my y-intercept is 0, 0. Now the point that I'm going to highlight is what matters. 6 comma 0, and let me put a different color here. 6 comma 0, 0, 0, 0, 0, 3, negative 9, and my axis of symmetry. So here we have our vertex. Here we have our axis of symmetry. And then we have our x-intercepts right here. And then my y-intercept right here. So let's go ahead and graph it. And we know it will open up. So let me put the point 0, 0, 6, 0 right here. So 7, there it is. My vertex is at 3, negative 9. So it's 1, 2, 3 down, all the way down here. And we know it opens up. So we have this parabola right here. And we have our axis of symmetry right here that it cuts it right in half at x is equal to positive 3. So we have our axis of symmetry, our two x-intercepts, and our y-intercept. Sorry, our vertex here. There's our vertex, there's our x-intercept, the point 6, 0, and then 0, 0, which is both my y-intercept and my x-intercept. So that's what we're going to be doing for these problems. Now we're going to do the same thing for question 2. The first step is to align f of x is equal to a x minus h squared plus k. A is negative 1. How do I know that? Because it's empty, it doesn't have a value, it's a negative. So it's automatically negative 1, which is less than 0. So it knows it's going to open down. It's a downward parabola. And what about the vertex? If we line them up, negative h is equal to negative 2, therefore h is 2, and k is equal to negative 1. So my vertex in this case is the point 2 comma negative 1. And then my axis of symmetry is x equal h, so it's x equal 2. Now I have to find is my x-intercept and my y-intercepts. So let's go ahead and do that. To find my x-intercepts, you let f of x equal 0 or y equal 0. So I get 0 equal negative x minus 2 squared minus 1. I'm going to bring the plus 1 over. So I'm going to have 1 equal negative 1 x minus 2 squared. Divide both sides by a negative 1. Now I have negative 1 is equal to x minus 2 squared. Then I'm going to take the square root of both sides. But wait a second. Can I take the square root of a negative number? No. So we do not know x-intercepts. There is no number, no real number that will give me a negative inside a root. But the y-intercept, so to find the y-intercept, let x is 0. So we identified that we will not have any x-intercepts, but let's find the y-intercept. So we have f of 0 is equal to negative 0 minus 2 squared minus 1. We get a negative 2 squared minus 1. Then we get a negative 4 minus 1, which is a negative 5. So my y-intercept is a point 0, negative 5. So let's start plotting what we know. 0, negative 5, that will be our 1, 2, 3, 4, 5 right there. And then what else do we know? We know our 2, negative 1. And then that's all I know. But I have an axis of symmetry that can tell me the distance. This is 2 away, so then I'm going to have 2 away. Because of symmetry, the axis of symmetry, it can give me this point. This point corresponds to 4, negative 5. I got that point from symmetry, and there's my graph. I have a downward parabola and matches from my point. And if you want to test it, find f of 4, and that should give you negative 5. Okay. The axis of symmetry was x equal to. So I have my axis of symmetry, I have my y-intercept, and no x-intercepts. Okay, and this was easy because it was already in vertex form. What happens if it's not in vertex form? For example, it looks like f of x is equal to ax squared plus bx plus c. We need it to convert this general form into vertex form. And there's two techniques. And one of the ways to do that is called completing the square. And there's different ways to do completing the square. There's a method that I use first, and we have to follow the steps. We first need to factor out the leading term. So we're going to have to factor out the 2. So f of x is equal to 2 parentheses x squared plus 10x plus 21. Now you're left with a factored of 2 right there. Now, what you normally do is you complete the square within a parentheses. That means you only focus on these two. The 21 is kind of left over. You don't touch that one. I like to, the way that I do it is a little bit different. And before I factor it out, I actually I get rid of the constant term first. That's what I do. So my technique is a little bit different. So I get rid of the constant by moving it over to the other side. F of x minus 42 is equal to 2x squared plus 20x. Now all the x's are on single side. So see how I keep the variables on one side. I keep the variables together. That's what I do. Now then I factor out a 2. Then I'm left with x squared plus 10x. And then over here, I have f of x minus 42. Now I complete the square here. That means I find the perfect square from 10x. So I'm going to take b, which is my 10, the middle, b divided by 2, and square it. That's the number that will go here. Be careful. That's what I need. So it's going to be b over 2, that's 10 over 2, and I'm going to square that. That's 5 over 2. I'm going to keep that in a parentheses. That's 25. That means I'm going to add 25 here. But in reality, what you did was added 2 times 25. That's 50. That means whatever I do to one side, I do to the other. So I have to add 50 here. I added 50. I added 50. Now I complete the square, have a 2 parentheses x plus 5 squared. Because all this, x squared plus 10x plus 25, is x plus 5 squared, which is the completing the perfect square trinomial there. Now on here, I have negative 42 and a positive 50. That gives me a positive 8 over on this side. And then I have f of x. Now it looks almost done. Now I need to isolate f of x. So it's going to be f of x, 2 parentheses, x plus 5 squared minus 8. Now everything is nice because I can identify that a is 2, h is negative 5, and k is negative 8. Now this is in the form f of x is equal to a x minus h squared plus k, which is exactly what we wanted. Let me fix this. This is now in the format f of x is equal to a x minus h squared plus k, where again, negative h is 5. That means that h is negative 5, and then k is negative 8. So then my vertex in this question is h comma k, which is the same as negative 5, negative 8. That means that x is equal to negative 5. That's my axis of symmetry. And then my a is 2. So we identified the vertex, and then we have to identify the x-intercepts and y-intercepts. So let's go ahead and do that. So then if we're finding the x-intercepts, let's put it over here. The x-intercepts, we have 0 equal to parentheses x plus 5 squared minus 8. So I'll bring the 8 over by adding 8, 2 times x plus 5 squared. We're going to have to take the square root of both sides, or before that, sorry, we divide both sides by 2. We get 4 equal x plus 5 squared. Now we take the square root, and we get two values. We get 2 is equal to x plus 5, negative 2 equal x plus 5. We get two values. X is equal to, subtract both sides by 5. We get negative 3, and then we get x is equal to negative 7 because we subtract 5. So then my x-intercepts are 0, excuse me. My x-intercepts are negative 3 comma 0 comma negative 7 comma 0. And my y-intercepts, I'm going to put a star here. Y-intercept is f of 0 is 2 times 0 plus 5 squared minus 8. Now I have 2 times 5 minus 8. That's going to give me 2. So my y-intercept is a 0.02. And there I have it. So I have my, I have my y-intercept, my x-intercepts, my axis of symmetry, and my vertex. I identified everything. X-intercepts, y-intercepts, vertex, and axis of symmetry, and there's my A. I know it's going to go upward. So we're going to do the same thing for question 4. Again, we're going to go very slow. So we start by, so step 1, isolate the variables on one side. So all variables on one side. All variables on a single side. So to do that, that means I'm going to move the 3 over. So it's going to look like f of x minus 3 is equal to negative x squared minus 2x. Then step 2, factor out any term to have 1 as a leading coefficient. So in this case, what do I have to factor out? I factor out a negative 1. Now I'm left with x squared plus 2x. I'm going to leave a space, and then over here I have f of x minus 3. Now I'm going to complete the square. Step 3, complete the square. What does that mean? I'm going to take the middle number, the 2. So take 2 divided by 2 and square it. 1 squared, that's 1. That means I'm going to add 1 here. But in reality, what did you actually do? Negative 1 times 1 is a minus 1. If you subtract a 1 from one side, I have to subtract a 1 from the other side. So now I have f of x minus 4 is equal to negative 1, parentheses, x. Now, because you have a 1 on the inside, it's a plus 1 quantity squared. Whatever number you have in here, say positive or negative, that's what condenses as x plus 1 quantity squared. So all this term becomes x plus 1 squared. Now that I have it almost done, step 4, I rewrite it. I rewrite as f of x only. So now I have f of x is equal to negative 1 parentheses x plus 1 quantity squared plus 4. Now I see that this is in vertex form, which is exactly what I wanted. Now I can pull what is h, what is k. So now a is going to be negative 1. That means it's less than 0, so it will open down. I know that negative h is 1. That means that h is negative 1. K is 4. So my vertex will be the point negative 1, 4. My axis of symmetry will be x is equal to negative 1. Now I'm almost done. I still need to find the x and the y-intercepts. So let's go ahead and do that. So then the x-intercepts, you find f of x is equal to 0. So 0 is equal to -1, parentheses x plus 1 squared plus 4. Bring the 4 over. -4 is -1 x plus 1 quantity squared. Divide by -1. Now I have 4 is equal to x plus 1 squared. Now take the square root of both sides. When that happens, I'm left with a plus and minus 2 is equal to x plus 1. I'm isolating x right now. So I have x plus 1 is equal to 2, x plus 1 equal minus 2. I isolate x and I get x is equal to 1. Subtract both sides by 1. Subtract both sides by 1, and I get -3. So my x-intercepts are 1, 0, -3, 0. And my y-intercept, you have f of 0 is equal to -1, 0 plus 1 squared plus 4. So that's -1 times 1 squared plus 4. That's -1 plus 4, that's 3. So 0, 3 is my y-intercept. So 0, 3 up here, I have 1, 0. Oh, excuse me. 1, 0. And then I have -3, 0. And then I have my vertex, which is the point -1, 4. So this is my vertex here. And it opens down. There's my axis of symmetry. There's my axis of symmetry at x equal -1. There's are my x-intercepts right here. And then there's my vertex right there. And my y-intercept. So I have all of the pieces, 2 x-intercepts, 1 y-intercept, my vertex, and my axis of symmetry. Now it's asking us, there's one more additional step to this one, and it's to find the domain and range. So let's talk about the domain and range. So the domain, so the domain of this parabola, it's all the possible x values. So from left to right, it's -infinity to positive infinity. In interval notation, the range is the lowest to the highest point. The lowest point, it's actually -infinity, and the highest point, the peak, it's 4, including 4. So you're going to put a bracket. A bracket is when you have inclusive, including 4. So the lowest point it will be -infinity. That's the possible x values. And then all the way to +4. Alrighty, so then for this important information we want to talk about is, let's say you have a quadratic function that looks like this. Now, this is in general form. Now, when you are identifying how many x-intercepts you are going to have, you can use this formula, b squared minus 4ac. If that value is 0, that means that you only have one unique x-intercept. When the value of b squared minus 4ac is greater than 0, then you will have at most 2 x-intercepts. If b squared minus 4ac is less than 0 or negative, you will not have x-intercepts. So for example, if we would look at the previous example, we have f of x was -x squared minus 2x plus 3. Now, if we use this formula, a is -1, b is -2, and c is 3. So let's find b squared minus 4ac and identify what that is. So b squared is -2 squared minus 4ac, which is 3 times -1. We get 4 plus 12 because -4 times 3 is a -12 times a -1 is a +12. That's 16. 16 is greater than 0. That means we will have two x-intercepts, which is true. We did indeed have two x-intercepts. Okay. Now, there is another technique to find the vertex other than completing the square. On the exam, I will require you to complete the square as part of mastering one of the techniques for Math 126. However, there's going to be some questions where I'm going to give you the liberty to actually use this vertex formula. Remember, you are not allowed to use any formulas on the test, so you will have to memorize this formula. And how do you do that? How do you evaluate or how do you find the vertex using the vertex formula? Well, the first thing you need to do is identify your H. So your H is H comma K. There's your vertex. The formula for finding H is negative B over 2A. Once you find H, you plug that into your function to find K. So let's do that together. Number 5. So we have f of x is equal to negative 3x squared plus 48x minus 165. So A is negative 3, B is 48, and C is negative 165. So how do I find my H comma K? My first component, it's negative B over 2A. So let's find that together. So negative B over 2A, it's negative 48 over 2 times negative 3. So that's negative 48 over negative 6. That gives me a positive 8. 8 times 6 is 48. So my H is 8. Now that I know what H is, I'm going to substitute that into my function. So f of 8, that's what I'm finding to be k. Negative 3 times 8 squared plus 48 times 8 minus 165. You will have a calculator in front of you, so please use that in handy to identify the value of k. So let's punch this on the calculator and identify that value. And that value will be 27. And that's K. So my vertex is the point 8 comma 27. I know and I identify that in this case, we will have my vertex to be 8 comma 27. Now that's using the formula. So this is using the formula. They're also asking us to use the vertex form or complete the square. So let's do that method. Let's complete the square. So the first thing is, remember, we move the 165 to one side by adding is equal to negative 3x squared plus 48x. Now we are going to factor out the negative 3 and we're going to have x squared minus 16x. We're going to leave a space because we're going to complete the square. Now we're going to take our middle term, negative 16 divided by 2 and square that number. That's negative 8. Square that number. That's 64. So I'm going to add 64 here. But what did you do actually? So you have a negative 3 and a 64. You're going to have to multiply 3 times 64. You actually subtracted a negative 198. That's actually a minus 198. Sorry, 192. Whatever you do to one side, you do to the other. So on this side, now you have f of x, 192 and 165. So it's 165 minus 192 on one side. I get minus 27 is equal to negative 3. All this condenses as x minus 8 quantity squared. Remember, it's your b over 2 squared. I'm almost done. Now I'm going to bring the 27 to the other side. And I have f of x is equal to negative 3 parentheses x minus 8 quantity squared plus 27. Oh, that's in vertex form, right? There's A, there's H, and there's K. H is 8, K is 27, and A is -3, which is exactly what we have on the other side. So the formula works and completing the square works. Okay. All righty. So then for the next few, we're almost done. The next one is actually an application problem that involves a quadratic function. So at the end of his career, Sherlock Holmes retired to a small farm country and took up a hobby of beekeeping. Being of an analytical mind, he could not watch the flea from one flower to the other flower. He formulated a mathematic model for the parabolic path that he saw from flower A to flower B. The path was given by this quadratic function. Notice the parabolic shape A is negative. A is negative 0.03, which is less than 0, so it opens down. We wish to find the maximum height. So that maximum height we're looking for, it's that vertex right there. We want to find the peak. So then, therefore, we are going to be using the formula for finding vertex. We want to find the maximum height. So the maximum height, if we use x equal negative b over 2a, in this case, a is negative 0.03, b is 1.8, and we don't need c. So let's substitute negative 1.8 divided by 2 times negative 0.03. If we punch this on our calculator, we're going to get 30. Is 30 our answer? No. We need to find the height. That only gives us the axis of symmetry, x equals 30. We need to find the height component. So we are going to substitute f of 30 into the function. Negative 0.03 times 30, quantity squared, plus 1.8 times 30 minus 24. Again, we are using our calculator, and we are going to get 3 inches. And how do we know it's inches? We are looking at the units here. So 3 inches will be the value of our maximum height. Okay. Next up is we're looking away. How far away are flowers A to B? So that means we're actually looking for the x-intercepts. X-intercept of the parabola. So to find that, we have f of x, set that equal to 0. 0 equal negative 0.03 x squared plus 1.8x minus 24. And then what we're going to do is actually get rid of our decimals, so 1, 2. So if we multiply by 100 first, so it's going to be 0 equal negative 3x squared, so 2 plus 180 x minus 2,400. Now I'm ready to complete the square here because I still want to find the x-intercepts, or I can divide everything by 3 or negative 3. So I get 0 equals, so divide by negative 3. I get x squared minus 60x plus 800. Now I'm going to try to factor. So how do I factor this trinomial? Negative a times c is 800, and then I have negative 60. Two numbers that multiply and give me 800, but add to negative 60, that's negative 40, negative 20. So we have x minus 40, x minus 20. Set this equal to 0. I find the distance x equal 40, x equal 20. So that means that which one's furthest? This one is 40 comma 0. This one is 20 comma 0. So the first flower is 20 inches away. The other one is 40 inches away. So flower A is 20 inches away. And then flower B is 40 comma 0, which is 40 inches away. those are the distance away from Sherlock. Okay. And we did that by factoring and identifying our x-intercepts. Alrighty, so the next thing we're going to be doing is using and creating quadratic models the same way that we did finding linear regressions. We're going to do using models with quadratic regressions. So what I'm going to do is I'm going to be projecting my calculator, and then you'll have an opportunity to see that with me, kind of guide you. So I probably will have ads, so I apologize for that. So let me go into my screen. And hopefully you guys are all looking at my screen here. Let me zoom in a little bit. So the first thing you want to do is you're going to go to your stat button right here, and then you're going to go to edit, and you're going to be placing on L1 your X values. So enter. L1 will be your X's. So I'm going to input, you're looking at your notes right now, 8, 10, 12, 18, 20, 23, enter, 40, enter, 55, enter, 60, enter. So you're right now looking at all of them in front of me, all the X values. So this is L1 and f of X is L2. And then you're going to hit 65 and then 70. If you mess up, you can go back and delete it. 70 and then 75. You should have 12 entries. Hit enter. Oh, see how I messed up on that one? What I'm going to do is I'm going to go up. I'm going to hit delete. So 70 and then 75 and then hit enter. Now I'm going to go to L2. I'm going to move my cursor to L2. Then I'm going to put 5. I'm going to put the other entries 5, 10. See how I have to go up again? Put 10, enter. And then 13, enter. 23, enter. 30, enter. 36, enter. 40, enter. 40. 35, 35. 30, 20. That's L2. 10, hit enter, and then 4. So I have all of my 12 entries from L1 and L2. Remember, the values from L1 was my X values. The values from Y are my L2. Once I have this stored, I'm going to go back to stat. I'm going to go to calc. So that means I'm going to move my cursor right here. Now you're using your graphing calculator. You're going to move over and you're going to go to quadratic regression 5, that quad, and you're going to hit enter 1 time, 2 times. There's my X list, L1, my Y list, L2. Enter, 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 calculate. So right now it's telling you your A, your B, and your C. So then that should match what we have on our lecture notes. So we're going to write our formula, y equal ax squared plus bx plus c. There's the value of a, negative 0.03. 2.79 minus 14.2. Now we're interested in graphing, so we're going to say y equals, so we're going to go to second stat plot. We want our plot to be on. So I want it on right here, enter. I want it on, enter, turn it on. You want to ensure it's on, and then you're going to go into y equal, and you're going to substitute that function that we just found. So you're going to type negative 0.034x, and then we're going to, so again, I'm going to use my cursors here. So it's a negative 0.034x. So there's my x value, and then I want that to be squared. And then plus, so there's my plus, I have to put it in there, plus 2.793. x right there, making sure that I have everything nice and written, minus 14.285. Then you're going to select graph. So see how you only see a part? So you want to go to zoom out a little bit. So 1, 2, zoom out and hit enter, enter. See how you're zooming in out and there's a little bit more. So you want to move your window a little bit more that right to that left side. Sorry, to that right side. So I'm going to fix my window. My minimum, I'm going to put for X, I'm going to put 0. Everything is more on this side, or I can plug in maybe a -2. I'll leave my X max. I'm going to change, oops, my window. Um, so let me switch this. Let me zoom out of my calculator. So I'm going to clear this out and I'm going to put -2. And then I'm going to bring this down and my max, let's put 100. I'm going to put my X scale, let's say to be a 10. And then, so it doesn't want to get the 10. And then I'm going to, my Y minimum and my X minimum, my Y scale, I'm going to change that to 5. Now I'm going to look at my graph. I want to go a little bit higher on my Y value, so I'm going to change my window to my maximum value to be maybe 100. My Y scale can change to 10, may perhaps. Now look at my graph. So I can see my parabola. It's opening down. Those little dots right there, that's the stat one. That's the quadratic regression. And right on top is that function that we see, that editor. So we are able to see both. The first one was the stat plot, second stat plot right there. We had to turn it on. And then we went to y equal, and then we plugged in the original equation that we found from the quadratic regression, and we selected graph. We really didn't see it at the beginning, so we had to change our window. So we had to modify our window, play around with the numbers, kind of move it around where we want the picture to be shown. Remember that you had that assignment for that first week. So just playing around with your window and then selecting graph and kind of see that parabolic shape that opens down because that makes sense. Our A is less than 0. So we're able to see our graph. So then I'm going to share back my screen. So we had those little dots, and then we had that graph right in front of it to determine our parabolic shape. And that ends our lecture. So we used a quadratic model to have regression, L1, L2. We substituted our values when we hit into our stat. We found this graph without plugging our y equal. Then we did our y equal, and then we were able to see the sketch right in front of it, like so. And then we modified our window. Okay, so hopefully you guys are taking notes. And that ends with lecture 2.1. Thank you. See you guys next time. Have a wonderful day. Bye bye.